All right, today is the second day about arithmetic problems. Yesterday we focused on sequence, and today we're going to focus more on series. Series involves like summation, so those are the ones that we're going to be focusing on today. So we need to be able to recognize whether or not it is arithmetic so that we know whether or not we can apply the different formulas that we're going to learn. And we're actually going to find the sum of them using a formula. So again, there's going to be another formula that you have to learn, and you have to recognize when do I use which formula. One of them you use to find a term in a sequence or a series, and the other one you use to find the sum of that series. So let's just review one really quick. So find the sum of the arithmetic sequence below. So since we're starting out with 1, we're going to have to find our first term. And then remember, because it's a sum, and because we see this sigma, that means we're going to have to add them all together in the end. So our first one is when n equals 1, so that'd be negative 4 plus 3. Instead of n, we'd put in 1 minus 1. Well, let's start simplifying. So negative 4, we can't simplify, plus 3, but 1 minus 1 is 0. So 3 times 0 is 0, minus 4 tells me negative 4 is my first term. Then for my second term, right, we're going to plug in 2. And remember that we don't stop until we get to that upper number, which is 5. So negative 4 plus 3, instead of n, we put 2 minus 1. So negative 4 plus 3, 2 minus 1 is 1, right? And now we can, 3 times 1 is 3, plus negative 4 is negative 1 for our second term. Then for our third term, negative 4 plus 3, but now our n is 3 minus 1. So we can simplify the parentheses, so we bring everything else over, and then 3 minus 1 is 2. 3 times 2 is 6, minus 4 would be 2 for our third term. Our fourth term, negative 4 plus 3, but again, instead of n, we're going to put 4 minus 1. Well, we can simplify the parentheses, so negative 4 plus 3 times 3. 3 times 3 is 9, plus negative 4 is 5, and then we need to find our fifth term. So negative 4 plus 3, instead of n, we put 5 minus 1. So we can simplify what's in the parentheses. So negative 4 plus 3, instead of 5 minus 1, it is 4. 3 times 4 is 12, minus 4 would be 8. So these are my first 5 terms. I found 1 through 5. And then because we see the sigma, it means that it's a summation, so now we need to add them together. So negative 4 plus negative 1 plus 2 plus 5 plus 8. And if we type that in our calculator, we get 10. So that tells me that the summation from n equals 1 to 5 of negative 4 plus 3 times the quantity n minus 1 is 10. So this idea of summations, we're going to keep working on. And the reason why we're going to learn a formula for this is, if you look at this summation below, they're asking you to find the summation from 1 to 53. That would be a lot of terms. That means we would have to find 53 different terms. And then we'd have to add them together. Well, that would take forever. So we want to find a more simple way to do that. So there's a formula that will make finding the summation of this easier. And quicker, I should say, because that's actually easy. It just takes a lot of time to make summation quicker. Okay, so remember, when we're doing this, you have to make sure that it's arithmetic, because this formula only works for an arithmetic series. Only works for an arithmetic series. So remember, we know we can use it if the series of numbers found by adding or subtracting the same number. So if we were given a series like this, right, where they just gave us the numbers, we could easily see that each time they were just adding 3. So if we can see that they're adding or subtracting the same amount each time in the series, then we can go ahead and use the formula that we're going to learn. Also, if it is an expression with no exponents. All right, so this original expression here, there are no exponents in it, so that tells me it's arithmetic, which means we're going to go ahead and be able to apply the formula. Same thing here. As soon as I see this, I don't see any exponents. It means that we could use the formula that we're going to learn for the summing, for adding the arithmetic series together. And also, you have to know when to use the different two arithmetic formulas. So if I'm going to use the formula that we're about to learn, the goal has to be to add the terms, not find the individual term or specific term. If we're trying to find a specific term, we do the one from yesterday, which was that a sub n equals a sub 1 plus n minus 1 times d, right? But if we're trying to find the summation, then this is the formula for finding the summation. So this formula would help us find the summation, whereas this formula helps us find individual terms. So just recognize that when you're doing this. What's my goal? Is my goal to find the summation, or is it to find a specific term? Okay. Other than that, a lot of this stuff really means the same thing. So the n is the total number of terms. The a sub 1 is the value of the first term. A sub n means the value of the last term. Right? Well, technically it means the value of the nth term, right? But if we're trying to find s sub n, then that would also be the last term in the sequence. And s sub n means the sum of all the terms through n. So if this was s sub 8, we would be summing the first 8. If it was s sub 2, we'd be summing the first 2 terms in the series. So let's actually use that formula to go ahead and find a summation. So this one, right away, I know that it's arithmetic because there's no exponents. All right, if there's no exponents at all, that tells me we're dealing with an arithmetic, in this case, series, because we're dealing with summations. So since we're dealing with an arithmetic series, we basically need to use the formula s sub n equals n over 2 times the quantity a sub 1 plus a sub n. All right, so if I'm going to actually do this problem, I need to know what's my n's, what's my a sub 1, and what's my a sub n. So our first step then is, when I'm looking at this, I notice that I don't actually know what this first term is, but I should be able to find it. I also know what my n is already, because my n should be my last term, and in this case, my last term is 53. So I know my n equals 53 because that's the last term, so we're summing 53 terms. I can find my a sub 1 by just plugging it into the formula. So step 1 is to find the first term. Well, the way we find the first term is we plug it into here. So my first term, which is a sub 1, we put 1 in place of the I, so it would be 7 times 1 minus 8. 7 times 1 would be 7. 7 minus 8 would be negative 1. So I know that my a sub 1, which is also my first term, is negative 1. I know that my last term is going to be the 53rd term, because that's what my summation tells me. And that's going to be my next step, because I also have to know what the value of that last term is. So step 2, find last term. Well, in this case, my last term is 53. So I'm finding a sub 53, which I can substitute into that again. 7i minus 8 should tell me what my 53rd term is. So a sub 53 equals 7 times 53 minus 8. And you can go ahead and type that in your calculator. and you should get that your 53rd term is 363. So now I found my first term, I found my last term. The only other value that's in there is that n, which we already know to be 53. So now that I've got the three pieces, I can go ahead and I can substitute into the formula. So we don't know S sub n, but we know that we're finding the 53 terms, so it's 53 over 2, and then a sub 1, which is negative 1, plus a sub n, which is 363. So now we can simplify this. You could either type it all in your calculator, or you could do it piece by piece. So this would be 362. So then when we go ahead and do this and type it into our calculator, we would find the sum of the first 53 terms is 9,593. And that's our final answer. So once we substitute it in, we simplify, and you get your final answer. So that should be really easy, right? What's your last term? Find the value of your first term, the value of your last term, your n, substitute in, and solve. So now you're going to go ahead and you're going to find number 1 on your own, and then you can go to the next video to view the last piece of that.